Welcome back, everybody. Today, we're going deep on the work of Judea Pearl.
Oh, cool.
Yeah. And
I'm excited about this one.
Yeah, real pioneer in AI.
Yeah.
And you've given us some really fascinating sources. One of them is called Judea Pearl, Causal Inference Pioneer in AI and Beyond.
Right.
And I'm excited to unpack this together. And
Yeah.
It seems like Pearl's work, it really challenges how we think about AI.
It does.
You know, moving beyond just pattern recognition and into the realm of understanding why things happen.
That's a great way to put it.
Yeah.
For a long time, AI was kind of stuck in this loop of just, finding these correlations.
Yeah.
And Pearl argued that, to truly understand the world, machines need a grasp of causality.
Mm-hmm.
Like, it's the difference between knowing that ice cream sales and sunburn rates both go up in the summer,
Right.
but one doesn't cause the other.
Okay.
They're just correlated.
I'm intrigued.
Yeah.
But before we get too deep into the why, can we back up a bit?
Sure.
Who is Judea Pearl? Yeah.
And what makes him such a big deal in AI?
Well, his background is actually surprisingly diverse.
Okay.
He started as an engineer, and then he delved into computer science and statistics.
Wow.
And even philosophy.
Really?
Yeah.
That's cool.
So that really comes through in his approach to AI.
Yeah, I can imagine.
And it's certainly earned him some serious recognition.
You're talking about the Turing Award, right?
I am.
AI's equivalent of the Nobel Prize.
Exactly.
That's a pretty clear sign. He's onto something big.
It is. And what he was onto was this fundamental problem with early AI.
Mm.
It could crunch data and spot patterns like nobody's business.
Yeah.
But it couldn't really understand cause and effect.
Okay.
It's like a super-powered calculator.
Uh-huh.
It's great at math, but not so good at understanding the real world. So an AI might notice that people buy more umbrellas when it rains,
Right.
but wouldn't understand that buying an umbrella doesn't cause the rain.
Precisely. And that lack of causal understanding can lead to some pretty misleading results.
Mm-hmm.
That's where Pearl's work with Bayesian networks comes in.
Okay.
It was a real breakthrough in how AI deals with uncertainty.
Okay. Bayesian networks sounds a little intimidating.
It does.
Break it down for me.
Sure.
What's so special about them?
So imagine you're a doctor trying to diagnose a patient.
Okay.
You have some symptoms, but you need to figure out the most likely cause.
Uh-huh.
Bayesian networks are kind of like a map of possibilities.
Okay.
Each symptom is a clue, and the network helps you weigh the evidence and calculate the probability of different illnesses.
So it's not just matching symptoms to a list.
Right.
It's about understanding how different pieces of information relate to each other.
Exactly. It's like putting together a puzzle where each piece of evidence updates the overall picture,
Okay.
makes the AI's diagnosis more accurate.
Yeah.
And this was a huge step towards AI that could reason about the world in a more sophisticated way.
Okay, so Bayesian networks helped AI deal with uncertainty.
Right.
But how did Pearl take that further and really push AI into the realm of causality?
Yeah.
I mean, how do you teach a machine to understand why things happen?
Well, he developed a whole set of concepts and tools for doing just that.
Okay.
One of the key ones is this idea of causal models. Think of them as mathematical recipes that describe how one thing causes another.
Okay.
It's like saying, if you mix flour and eggs and sugar and bake them at 350 degrees, you'll get a cake.
Right.
These models allow us to represent cause and effect relationships in a way that AI can understand.
So instead of just observing patterns, we're giving AI a way to represent the actual mechanisms behind those patterns.
That's right.
But how do you make those models visual?
Yeah.
It seems like things could get pretty complex pretty quickly.
They do.
Yeah.
And that's where causal diagrams come in.
Okay.
They're like flowcharts that map out the cause and effect relationships within a system. So imagine a diagram showing how things like rainfall and soil quality and temperature all influence crop yield.
Yeah.
It helps us visualize the complex interplay of factors and understand how intervening in one area might affect the others.
Okay, that makes sense.
Yeah.
But what about predicting what will happen if we actually make a change?
Right.
Like, what if we introduce a new irrigation system?
Sure.
Can these causal diagrams help us with that?
You're thinking like a true causal thinker.
Right.
And the answer is yes. That's where do calculus comes in.
Okay.
It's a mathematical tool that lets us simulate interventions and predict their effects.
So instead of just passively observing the world, we can use AI to experiment and see how different actions might play out.
Exactly. Let's go back to that farming example.
Okay.
Using do calculus, you could simulate what would happen to crop yield if you implemented that new irrigation system.
Okay.
taking into account all the other factors in the causal diagram. It's like running a virtual experiment to test different scenarios before making real-world decisions.
That's fascinating. So by combining causal models and diagrams and do calculus,
Yes.
we're giving AI the tools to not only understand cause and effect, but also to predict the consequences of our actions.
Precise.
That's a huge step towards making AI more powerful and reliable.
It
And
is.
ultimately more beneficial to humanity.
Absolutely.
This is incredible.
Yeah.
So we've gone from AI that simply spots patterns to AI that can reason about why things happen.
Right.
And even predict the effects of change.
Yep.
It's like we've unlocked a whole new level of understanding,
We have.
but I'm sure it doesn't stop there, right?
It does not.
What else did Pearl contribute to the world of AI?
Well, one of the things I find most fascinating about Pearl's work is this concept of the ladder of causation.
A ladder of causation, huh?
Yeah.
That sounds intriguing.
It's a way of understanding the different levels of reasoning that AI
Right?
and even humans can achieve.
What are the different rungs on this ladder?
Well, the first rung is what Pearl calls association. This is where we're just observing patterns and correlations.
Yeah.
Think back to our earlier example about AI noticing that people buy umbrellas when it rains.
Yeah.
That's association.
Okay.
Recognizing a pattern, but not necessarily understanding the cause.
So it's like noticing that two things happen together,
Right.
but not knowing if one causes the other or if there's some other hidden factor at play.
Exactly. And as we talked about before, confusing correlation with causation can lead to all sorts of problems.
Right.
But to really understand the world, we need to climb higher on the ladder.
Okay.
The next rung is called intervention.
Intervention.
Yeah,
So this is where we start actively interacting with the world, not just passively observing it.
precisely. This is where we move beyond just seeing that umbrellas and rain go together.
Okay.
And we start asking, what happens if I give someone an umbrella? Will it make it rain?
Right.
Of course not. But the point is that by intervening, we can start to disentangle correlation from causation.
I see. So it's like running an experiment to see what happens when you change something in the system.
Exactly.
Okay, that makes a lot of sense.
Yeah.
But what about the top rung of the ladder? What's that all about?
The top rung is where things get really interesting.
Okay.
It's the realm of counterfactuals, which is all about asking what-if questions.
Counterfactual. Okay, that sounds pretty complex.
It can be.
Can you give me an example?
Sure, imagine a doctor treating a patient who, unfortunately, didn't respond well to a particular medication,
Okay.
using counterfactual reasoning.
Uh-huh.
The doctor might ask, what if I would prescribed a different medication? Would the patient's outcome have been better?
So it's like the doctor is mentally rewinding time
Right.
and replaying the scenario with different choices to
Yeah.
see if there might have been a better path.
Exactly. We use counterfactual thinking all the time in our lives.
Yeah.
What if I had studied harder for that exam? What if I had taken that other job offer? It's a way of learning from past experiences and making better decisions in the future.
That makes sense. But isn't that incredibly difficult to do?
It is.
Especially for a machine. I mean,
Yeah.
we can't actually change the past.
You're right. We can't change the past.
Right.
But we can use our knowledge of the world and how things work to construct these what-if scenarios in our minds.
Okay.
And Pearl argues that being able to think counterfactually is a key part of true intelligence, something that AI needs to master if it wants to reach its full potential.
Okay, I'm starting to see why this is the top rung of the ladder.
Yeah,
It requires a deeper level of understanding about how the world works,
it does.
about cause and effect, and about the potential consequences of different actions.
Right.
It's like AI is graduating from simply reacting to the world
Yes.
to actually reasoning about it.
Exactly. And the potential applications of counterfactual AI are immense.
So like, what are some examples?
Well, imagine an AI that can help doctors choose the best treatment plan for a patient by simulating the likely outcomes of different options. Or an AI that can help policymakers understand the long-term effects of different policies
Yeah,
before they're implemented.
that would be amazing.
It would.
It sounds like counterfactual AI could revolutionize so many fields.
I think so.
But there must be challenges too, right?
There are.
I mean, isn't it dangerous to give machines the ability to think about what-if scenarios?
Yeah, that's a good point.
What if they start questioning their own programming or the decisions made by humans?
Those are very important questions.
Yeah.
And ones that researchers are actively grappling with as we develop more sophisticated AI systems. One of the key concerns is ensuring that these systems are aligned with human values and goals.
Yeah.
We don't want AI making decisions based on counterfactual scenarios that lead to harmful outcomes.
Right, right.
You have to be very careful about that.
It sounds like there's a real need for ethical guidelines and oversight as we venture further into this realm of counterfactual AI.
Absolutely.
Yeah.
It's crucial that we develop these powerful technologies responsibly
Yeah.
and make sure they're used for the benefit of humanity, not to our detriment.
So we've covered the different rungs of the ladder of causation.
We have.
And we've touched on some of the ethical concerns related to counterfactual AI.
Right.
But I'm also curious about the criticisms Pearl faced when he first introduced these ideas.
Yeah.
I mean, not everyone embraced his vision, right?
That's right. Some researchers were skeptical about the practical implications of causal inference in AI.
Why is that?
They argued that it was too complex,
Okay.
too computationally demanding,
Uh-huh.
and that the focus on causality would slow down progress in other areas of AI. Like deep learning.
Oh, okay. So it was a bit of a paradigm shift.
What?
Moving away from the purely data-driven approach of deep learning.
Right.
And embracing this more complex causal way of thinking.
Exactly.
How did Pearl respond to these criticisms?
He acknowledged the challenges of causal inference, but he argued that it wasn't meant to replace existing AI techniques, but to enhance them.
So it's not an either situation.
Right.
It's about integrating causal reasoning into existing AI frameworks.
Yes.
To make them more robust and reliable.
Exactly.
And ultimately more beneficial to society.
That's the goal.
He emphasized that causality brings qualities like transparency and fairness and accountability to AI.
It does.
Which are essential if we want to create trustworthy systems.
Absolutely.
He believed that by combining the strengths of deep learning with the insights of causal inference, we could build a new generation of AI that's both powerful and responsible.
I think that's a really important point.
That makes a lot of sense.
Yeah.
It's about finding the right balance between the power of data-driven learning and the depth of causal understanding.
That's right.
But with all this talk about theory and concepts, I'm curious about the practical side of things.
Sure.
How are Pearl's ideas actually being applied in the real world today?
That's a great question, and one we'll definitely explore further. Okay. But before we jump into specific examples, there's one more key aspect of Pearl's work that I think is worth discussing.
Okay, what's that?
The idea of causal discovery.
Causal discovery. Okay, I'm all ears. What is that all about?
Well, so far, we've talked about how we can use causal models and diagrams to represent and reason about cause and effect relationships.
Right.
But what if we don't know those relationships in advance?
Okay.
What if we need to uncover them from data? That's where causal discovery comes in.
Interesting.
It's like being a detective using data to piece together the causal story behind a phenomenon.
So instead of relying on humans to tell the AI how things are connected, we're asking it to figure it out on its own.
Precisely.
Yeah.
And this is a huge area of research in causal AI.
Wow.
Imagine an AI that can analyze a massive data set of medical records and uncover hidden causal relationships between lifestyle factors and genetic predispositions and disease outcomes. Or an AI that can sift through economic data and identify the true drivers of economic growth.
Those are some pretty powerful examples. It sounds like causal discovery could lead to all sorts of breakthroughs in different fields.
I think so.
But how does it actually work?
Yeah.
How can AI uncover these hidden causal relationships?
Well, it's a complex process, but at a high level, it involves looking for patterns in the data that are consistent with causal relationships, as opposed to just correlations.
Okay.
It also often involves using techniques like randomized controlled trials, where you randomly assign subjects to different treatment groups to see if there's a causal effect.
So it sounds like a combination of clever algorithms and good old-fashioned experimental design.
That's a good way to put it.
But with all the data available today, I imagine there are still challenges to overcome.
Definitely. One of the biggest challenges is dealing with confounding variables.
Confounding variables. Okay, can you give me an example of a confounding variable?
Sure.
It seems like those could really throw off the AI's analysis.
Absolutely.
Yeah.
Let's say we're trying to understand the relationship between coffee consumption and heart disease.
Okay.
We might find a correlation between the two, but that doesn't necessarily mean that coffee causes heart disease.
Right.
It could be that people who drink a lot of coffee also tend to smoke cigarettes.
Oh, okay.
And smoking is the true cause of the increased risk of heart disease.
Ah. So smoking would be the confounding variable in this case.
It would.
It's a hidden factor that's linked to both coffee consumption and heart disease,
Right.
making it seem like there's a direct causal link between the two when there might not be.
Exactly.
How does causal discovery deal with these confounding variables?
There are various techniques that researchers use.
Okay.
One common approach is to statistically control for potential confounders by including them in the analysis. This allows you to isolate the true effect of the variable you're interested in.
Okay.
In this case, coffee consumption,
Uh-huh.
while accounting for the influence of other factors.
Okay, so it's about being really careful about how you analyze the data and making sure you're not jumping to conclusions based on spurious correlations.
Exactly. It's very important to be rigorous.
But even with these sophisticated techniques, there must still be limitations to what AI can discover about causality, right?
You're absolutely right.
Okay.
Causal discovery is a challenging task, and there are inherent limitations.
Like what?
Well, for example, we can never be 100% certain about the true causal relationships underlying a phenomena. There's always the possibility that there are hidden confounders that we haven't accounted for.
Right.
Or that the causal relationships are more complex than we initially thought.
So it's about being humble and acknowledging the limitations of our knowledge, even when we're using powerful AI tools.
Exactly. Causal discovery isn't about finding definitive answers.
Okay.
It's about building the best possible understanding of the world based on the available data and our current knowledge.
I appreciate that perspective. It seems like a good reminder that even in the age of AI, we still need to be critical thinkers and question our assumptions.
Precisely.
Yeah.
And as we delve deeper into Pearl's work, we'll see how his ideas encourage us to think more critically about the world around us.
Okay.
And to be more careful about the conclusions we draw from data.
I'm eager to learn more. What else can you tell me about how Pearl's ideas are being used in specific fields like healthcare or economics or social sciences? I mean, I'm dying to see how this all plays out in the real world.
Well, there's so many cool real-world applications of this stuff.
Yeah, let's hear it.
Let's start with healthcare.
Okay.
Pearl's ideas are having a big impact on personalized medicine.
Okay.
Instead of relying on just general treatment guidelines,
Yeah.
doctors can use AI,
Uh-huh.
powered by causal reasoning,
Okay.
to figure out which treatments are most effective for individual patients based on their specific, characteristics and medical history.
So it's like moving away from a one-size-fits-all approach
Right.
to healthcare and towards a more tailored, precise approach?
It is, and that's really promising, I think.
Yeah, it really is.
And it goes beyond just, choosing the right medication.
Yeah.
Causal inference can help predict how patients might respond to different treatments.
Okay.
Imagine being able to anticipate potential side effects or complications before they even happen.
Wow.
That could lead to better outcomes
Yeah.
and even save lives.
That's a game changer.
It is.
And it seems like this could be applied on a larger scale too, right?
Yeah.
Not just for individual patients, but for entire populations.
Absolutely. Causal inference is already being used to improve public health initiatives.
Okay.
For example, researchers are using it to understand how diseases spread, identify risk factors,
Uh-huh.
and evaluate the effectiveness of interventions like vaccination programs.
Wow. So Pearl's work is literally helping us fight diseases and improve global health.
It is.
That's incredible.
Yeah, it's pretty amazing.
But I'm curious to know how these ideas are being used outside of healthcare.
Yeah.
What about other fields like economics or the social sciences?
Those are great examples.
Yeah.
In economics, causal inference is being used to analyze the impact of government policies,
Okay.
such as tax changes or new regulations.
Hmm.
Imagine being able to predict the ripple effects of these policies before they're implemented.
Yeah, that would be huge.
It would.
It could help governments make more informed decisions that benefit everyone.
Exactly. And in the social sciences, researchers are using causal inference to study complex societal issues.
Like what?
Well, for instance, understanding the impact of education on income inequality. Or the role of social media in shaping political opinions.
So it's not just about crunching numbers.
Right.
It's about using data to understand the underlying causes of complex social problems.
It is.
And then using that knowledge to design better solutions.
Precisely. And it's not just academics and policymakers who are embracing these ideas.
Okay, who else?
The business world is catching on as well.
Really?
Yeah.
Okay, I'm intrigued. Tell me more about how businesses are using these concepts.
Well, think about how companies target their advertising campaigns.
Okay.
Instead of just blasting out generic ads, they can use causal AI to personalize their messages and offers to specific customers
Okay.
based on, their past behavior and preferences and even demographics.
So it's like moving away from mass marketing and towards a more personalized, targeted approach.
Yeah, and it seems like that would be more effective
Yeah.
for both the business and the consumer.
Right. Exactly.
And it goes beyond just advertising.
Hmm.
Companies are using causal inference to optimize their pricing strategies,
Okay.
improve customer service,
Mhm.
and even design better products.
That's amazing to see how these ideas are being applied in so many different ways.
It is.
From healthcare to economics to business and beyond.
Yeah, it really
It's
is.
a real testament to the power of Judea Pearl's work. But as we wrap up this deep dive, I want to bring it back to our listeners.
Sure.
Why should they care about causal reasoning?
Right.
How can they apply these concepts in their own lives?
That's a great question.
Yeah.
I think the most important takeaway is that causal reasoning is not just for scientists or AI experts.
Okay.
It's a way of thinking that can benefit everyone.
Mm.
By understanding the difference between correlation and causation, we can all make more informed decisions in every aspect of our lives.
So it's about becoming more critical thinkers,
It is.
questioning assumptions,
Yeah.
not jumping to conclusions based on superficial patterns.
Right. And as AI becomes more pervasive in our lives, it's crucial that we understand the principles behind it.
Yeah, I agree.
Causal reasoning gives us the tools to interpret the outputs of AI systems
Okay.
and make sure they're being used ethically and responsibly.
So it's like empowering ourselves to be informed citizens in an increasingly AI-driven world.
Exactly. And I think that's a great message to leave our listeners with. Stay curious,
Uh-huh.
keep learning, and don't be afraid to ask why.
I love it.
By embracing causal reasoning, we can all make better decisions,
Yeah.
understand the world more deeply, and navigate the future with greater confidence.
That's a powerful thought.
It is.
And a huge thank you to our expert for this incredible deep dive into the world of Judea Pearl and causal reasoning.
Oh, it was my pleasure.
I think I can speak for all of us when I say that we've learned a ton today.
I hope so.
And to our listeners, thank you for joining us.
Yeah, thanks for listening.
We'll see you next time.
See you later.